guys joined us. I'm really excited today to have three fantastic process engineers who are alumni from our program joining us. So we have Caleb and Victoria and Shannon. Caleb and Shannon graduated in 2019 with bachelor's degrees from the program, and Victoria graduated in 2016 with a BS from the ChemE department. And all three are currently, Alan, I'm just going to stick you on mute for a second. All three are currently process engineers in a variety of industries. So this is also a great opportunity for everybody who's joining us to kind of learn what a process engineer is, because that's very unique to the chemical engineering profession. So like last week, we're going to get started with just brief intros from all of our panelists. And then we have some set questions that we sort of prepared ahead of time that we'll use to kick off the event. And then we'll definitely have time for audience questions, which again, audience members, you can submit via the Slido link or in chat, or raise your hand and we'll call on you from audience setting. Caleb, Victoria, Shannon, good to go? All right, Victoria, I'm going to hand it off to you to get us started. If you can just give us like brief introduction, kind of your current job, current organization, anything else you just want to share, and then we'll certainly like follow up with some questions. But if you don't mind kicking us off, that would be great.
Yeah. So I've been at the same facility for almost 8 years. I'm up in Anacortes, so stayed close to Seattle, which is nice. I work for Major Oil, so I work with Marathon Petroleum Company, and as Professor Nance said, I've been a process engineer there for a while, so I've gone through various, I'm going to refer to them as units. It's a process unit. So I've covered a lot of different technologies and process units in my time up in Anacortes. I've also done a little bit of time as process controls. So that's an area I think seniors get into that a little bit more, but that's another interesting niche, very niche chemical engineer position that we can go into.
Awesome, thanks. Yeah, we'll definitely follow up on that. I've got some questions specific to translation of ChemE coursework to your jobs today. All right, Shannon, will you give us a brief intro? And again, feel free to interpret that broadly.
So as you mentioned, in 2019, I graduated and I was hired on at IM Flash, which quickly became Micron Technology. And then in the last 2 years, it became Texas Instruments. I started as a quality role department. And then since then, I've moved on to process engineering and becoming a process owner, which has been pretty exciting. And I think, so it's kind of my history.
Awesome. Thank you. All right. And Caleb, you're last but not least on our list. If you can give a brief intro and overview of, again, however you choose to interpret introduction.
Sure. I'm Caleb. Like Nance said, I graduated in 2019. Hired on with Shell first as an intern and then as a full-time process engineer. Shell sold the refinery to PEMEX, so it's now the PEMEX Deer Park refinery in the Houston area. And I'm doing catalytic cracking is the unit that I'm stationed to, but I've done utilities and control systems as well.
Awesome. All right. I think like there's a few, I always take notes on this. And so our participants will see a few keywords about like units, so unit operations, process control, like process engineering, quality control, Shannon, which I know was a part you mentioned. Can y'all kind of, and you can answer this in whatever order, can y'all describe kind of what your day-to-day job looks like? And in answering that, what you define as a process engineer? Like, what does it mean to be a process engineer, and specifically like within your day-to-day job? What do you do?
My gosh.
Wait, hang on, we've got a few. All right, and anybody who wants to answer that first, please feel free to read on that.
I can start.
Go for it.
Okay. So our company doesn't really give us a definition of a process engineer. They just put you on the job and then give you some expectations of here's some tasks, and then they ask you to figure out your job description. So I can't give you here's what we do. What I've kind of distilled it down to is you're kind of the advocate for technical safety, process safety, cost optimization and any other constraint that they give you to kind of meet the business needs in the technology space, and then kind of provide technical guidance to the business side. It's a weird spot to be, and I'm sure it changes quite a bit depending on what company you're in.
And just a quick follow-up, when you say kind of the business side as well as the technical side, are you the primary point of contact interfacing between those, like in your role? Is that do you kind of get to be the interface that sort of coordinates between different units or different divisions that might need to talk to each other occasionally?
One of them, so in our company, and I'm sure it's similar to other refineries, there's different layers. So there's like purely finance, and then there's the economists that would look at, they have a little bit of process knowledge, but mostly business knowledge. And then the process engineer is kind of squarely in the middle. And then you've got your technical experts and your operations experts on the other end of the spectrum that are not as focused on operation, or not as focused on economics, more focused on the day-to-day and the process technology.
Yeah, got it. Okay, well, definitely some key points we'll follow up on there. Shannon, what about you? What's your day-to-day like, and what does it mean in your job to be a process engineer?
Yeah, I think really similar to Caleb. I think being a process engineer, specifically in my case, I'm considered a process owner. So I work in CVD, which is chemical vapor deposition. Not sure if that's familiar to anyone, but anyways, so like as a process owner and process engineer, I am quite literally the owner of my workstation, my film that I own. So I'm considered, which maybe is scary, but I consider the SME where people, so we have an integration team, we have other modules, right? I don't know how familiar people are with semiconductors, but if there's an issue downstream, upstream, some kind of integration change that they want to make, I am kind of the person who figures out how to make those changes. And so my day-to-day, what I'd like to do is a lot of testing and continuously doing like DOEs, how can I improve my process, right? But aside, also like Caleb's saying, there's also yield opportunities, cost opportunities where you're given these constraints on how you're going to make your process better, but also it's up to you as a process owner to figure out how you can improve your workstation. Like no one's going to tell you what to do. You need to figure out how to do it. And I think that's kind of what separates an engineer from a good engineer. And so I think that's kind of the biggest thing.
I'm sure we'll have some questions on that level of independence and growing into that level of independence as well, that I imagine all three of you can definitely comment on. Victoria, do you want to first give us kind of your take on your sort of summary of what your day-to-day is and what process engineering is to you and your job?
Yeah, I mean, so I have a lot of similarities with Caleb and honestly with Shannon as well. But one thing that's fun about process engineering, I call it the three-headed monster. We're one of the three heads. So you got your folks who are in economics. They're figuring out, what product do we need? How can we maximize profit? And they're not so focused on operations of how do we get there so much as telling us the priorities. Here's what we need. And then operations, they're focused on, okay, how do I run the refinery? How do I keep everything going? I need to worry about maintenance. And we are the ones that kind of liaison between the two of them. We understand both sides. And that's where we kind of come in between those two and say, all right, so if you want to make more of this, here's how you can do it within the boundaries that are our process conditions. The other big aspect that I really focus on is process safety. So I tell people like, operations, they know the unit, they know what they're working with, but we're really the only ones who have a great understanding of what's inside of the pipes. And so we have to take that knowledge and that understanding and apply it to day-to-day optimization, as well as process safety, and making sure that, if we make a decision, that it's not going to cause an overpressure scenario. So that's another key aspect, I think, that plays into truly my day-to-day job, what I do every day.
Yeah, so it sounds like you really have the accountability and sort of the oversight of specifically the safety aspect in terms of how that influences the day-to-day operations and how each individual unit within that larger operational process actually functions, right?
Yep.
Which I think is a good point to emphasize and distinguishes potentially from technician or maybe other engineering roles as well.
Sure.
So I'm curious because you're all in. I really appreciate that you noted the similarities that you have, but you're all in slightly different kind of companies and industries. How did you pick that? Like, did you know you wanted to be a process engineer, I guess, is one part of this question. But how did you pick which industry that you wanted to go into? Was it the industry that drove you wanting to be a process engineer in that industry, or was it wanting to be a process engineer and then kind of finding a fit in a type of company or application area that interests you? Maybe we'll start with Shannon on answering that.
Yeah, that's a good question. So I didn't really know, honestly, probably like most of you, I just wanted a job. And I think I did the IM Flash at the career fair. And so I knew I was interested in that. And I had also known Amanda Levinson, who was a process engineer at Intel. And so I kind of had an idea of these people who seemed to be killing it at their jobs and were really happy. And so I knew that I think I knew I wanted to be a process engineer. I wasn't super sure on the industry. But I think kind of why I feel like semiconductors has been like a good home for me is that it's continuously growing. We need more computer chips, and it's kind of cyclic. It has its up and downs, but overall it's been pretty stable. And I think just kind of the empowerment that TI gives you as an engineer and to be able to make decisions has just been a good fit for me. So that's kind of why I chose it.
Yeah, and Caleb and Victoria, you're in, I guess, more similar industries in a way in terms of sort of thinking about oil and gas and petroleum. How did y'all get interested in that area of application? Was it something that you came into ChemE with? Was it something that you like kind of through internships or other experiences explored? Like how did you settle on working at Marathon and working at PEMEX for kind of that, in addition to maybe like why a process engineer role at those companies, but how did y'all settle on that industry?
Yeah, I did 5 internships over the course of my pre-graduation career, and that was a way for me at least to explore different fields. So I did 3 internships at a national lab in research. Decided I didn't want to spend my life begging for money, which is not research, but that's how I perceived it at the time. And then I spent an internship out at a nuclear facility, out at Hanford. And again, I enjoyed my time out there, but I decided working with government contractors, I didn't really enjoy that as much. So then I tried private industry, and really focused more on large scale manufacturing. So that was kind of the other aspect I was looking at is research, but that was all bench scale, very small. Which was interesting, but I didn't enjoy that as much. So my final internship, which was with Marathon, where I had the combination of I enjoyed the company, I enjoyed the culture, and kind of how corporate America worked, as well as just the scale that I was working at. That all tied together really nicely for me and said, "Hey, this is your career path. This is where you want to go."
Yeah. Nice. Yeah, I like that. Also touching upon the fact that you worked in every internship didn't have to be related to every other internship, right? Like they were all kind of unique, distinct experiences that you could take something away from, but then use that kind of to further refine where, not to put a pun on the field, but like to further refine like what industry you ended up in. Caleb, how was your process? Was there similarities, differences, and kind of identifying PEMEX as somewhere you wanted to work, the oil and gas, like kind of what was your approach for this?
Pretty different, I guess, to the other two. So I did a job shadow in high school with a family member who was a safety representative at a refinery. And I thought it was the most boring thing that a person could do. So I ended up following around one of the process engineers for the day. And funny enough, he actually now works with me here at PEMEX. But he was a utilities engineer and taught me about the cat cracker and all these different technologies. And so that had me interested. So then after high school, I took a job on a maintenance crew at that refinery and kind of learned a different perspective on the business and got to meet, a lot of operators, a lot of maintenance techs, and some instrument and electrical guys just doing odd jobs around the plant. And so that got me kind of an in with the business, but also a way to evaluate some of the different jobs that was in the Anacortes area. And then once I got in for my first Shell internship, then I realized, I kind of really like working in the Gulf Coast. And so ended up moving to the Shell refinery here in Houston. And when PEMEX came in and bought, a good like 30% of the people left because there's reasons you wouldn't want to work for the company. But I got moved for a short period of time to work on contracts for the sale, which was interesting. And so I just kind of stuck around along for the ride, and I don't know, haven't found another place to go. So, and I'm really liking it here.
Yeah, that's, I think, also like really good perspective to see such a different route of like how you came into a job too. I think a couple of, like y'all mentioned a couple of things I want to touch upon. I'm going to give a plug to everybody in the audience that I've got a couple more kind of preset questions that I'm going to use to follow up on some of the points that our panelists have made. But if you have questions, again, either stick them in chat, direct message to me, or public message is fine, or in the Slido would be great. I'll start feeding the private message questions here in a minute. You all mentioned, okay, there's kind of two parts to this. You're all working in fairly large companies. And you also kind of mentioned this sort of ability, like independence that you have with your job. Kind of, I think, Caleb, you mentioned that like they put you on the job and you kind of you have to kind of figure out what you're doing or how you're doing it. Do you correlate those two? Like, do you see kind of your ability to have independence and to do a lot of different things tied into working for a large company as opposed to working for a small company? Was there a process to getting to that level of independence that you feel like was part of the job and part of kind of the training of the, like, on the job training that you experienced? I'm kind of asking broad questions to sort of just like any part that you relate to. Would love to hear your insights and experiences on. And I'll open that to whoever wants to respond.
My husband's also a chemical engineer, and we spend a lot of time discussing these things. He works at a much smaller private company. And I'd say that as an engineer, a level of independence is critical in manufacturing. You have to be able to troubleshoot and problem solve on your own. In my role out at the refinery, it's more critical that I can think on my feet, that I can make decisions based off of the information I have at the time. So that's a little bit different than other industries or smaller companies even. What skills you need to be successful, but that independence is still important. I think what I've seen is being at a large company, it was kind of nice for me at least, of you do have to be independent. They did put me on a unit. You got to be making decisions. You need to be interfacing with all these people. But at the same time, these are large, expensive facilities. And so it's not really a sink or swim situation. There's always people who you can bounce questions off of, who, you can in a meeting say, hey, this is what I think, but I'll get back to you. And then go cross-check your answers, make sure you did due diligence. And then, do come back and say, yes, I'm confirming or changing what I was thinking. So there's that independence, but there's also a good support system, because it's important not to make snap decisions.
And it sounds like there's institutional structure for knowledge in addition to physical structure that's present and sort of operational structure that's present. Caleb, I think you had something you wanted to add on or respond to on this as well.
Yeah, for our company, it's about 6 months to a year after you hire on. Even for some experienced hires where you don't get assigned to a unit, they just have you learn the company and start doing kind of petty tasks. And then once they put you on the unit, they establish a certain amount of base work, which is stuff that regardless of your experience, if you're assigned to that job, you just have to get it done. And so your learning curve kind of crosses your base work, where at first you're flooded with all this stuff that you don't know how to do that you have to get done. But then as you progress, you understand the equipment better and the work processes. Then you have this gap where your ability exceeds your base work. And then at least in our company, your extra time is spent towards going out and looking for things that you can improve, ways to save money or make more money. And so once you get the experience that you can cover the base expectations, then you can go look for ways to kind of boost your resume or learn something new, or take credit for some cost saving initiative that you start.
Yeah, I think that's like a really that I think is like kind of a cool approach that also some other industries use, where you kind of get global perspective of everything, and then you sort of deep dive into specific directions, which I imagine might also give more insights later on and sort of mobility within the company, where you could then kind of have a better understanding. There might be different directions within sort of your career trajectory you might then be able to take. I know some of our Boeing alumni have commented on that about working at Boeing, where it allows them to move laterally in addition to kind of moving up the sort of career ladder as well. That wasn't really a question; it's more of a comment or observation. But Shannon, I'm curious if the same question to you, but thinking in the context of having a company that's changed hands multiple times. I guess in sort of thinking about this question of moving towards independence and the sort of structural organization that enables that independence, was that also impacted by the fact that your like IM Flash was turned over?
Yeah, it is really interesting, especially the transition between Micron and Texas Instruments. So I guess it's kind of interesting because I've had the opportunity to work for 3 different companies, all working in the same location,
right,
and seeing how, getting the opportunity, I guess, to be exposed to different company cultures. But I guess like touching upon kind of both what Caleb and Victoria said is, yes, you're very independent and like expected to be in your role, but you're not just kind of thrown in here like immediately and to figure out things. Kind of like Caleb said, there's a certain period of time where you get to maybe shadow people or be on the floor and really get to see the tools and equipment. Like you're going to have support, but again, it is important that there's like a learning curve expected where you're just going to have to be able to make your own engineering decisions. And there's always people to ask, right? Like your manager, that's what your manager's for, and that's what your team's for. It is just a learning curve, I think, and very quick one, I think, as a process engineer.
Yeah, so 2 questions that have come in, one in a private message and the other one on Slido related to this. I'll ask the one on Slido first. What you all kind of mentioned aspects of the environment, the culture. What is your work environment like? Like collaborative, like independent work? I mean, like, again, broad question, openly interpreted. How do you describe your work environment? And that was for all panelists, so whoever again wants to.
Yeah. So for me, I guess in terms of my actual team, I would say it's interesting because I like I mentioned previously, there's other modules. So, for example, I'm in CVD, but there's like PVD or CMP, plasma, right? Like these other different process groups. And so I find that like for me, I actually work with a lot more of the different modules. So it's a lot of interworking, as well as like our process integration team or our quality team when I'm trying to make changes or conversions to my process, a little bit more so than I actually my direct team in certain cases. I think there's always a collaborative aspect in terms of bouncing ideas off each other, like new learnings, like that's always continuous. Like I'm obviously talking to my team all the time. But in terms of my actual process, kind of my unit process, just understanding that in wafer manufacturing, there's downstream effects and upstream, and it's right because it's kind of an assembly line. So my step is obviously influencing other people, and they're influencing me, and so that's a lot of working together in that way.
Yeah, team aspects are definitely something, as I'm sure y'all recall from particularly senior year courses, are also introduce challenges in addition to opportunities, right? Of kind of getting this really interdisciplinary, collaborative nature. But I'll let if Caleb or Victoria have a reflection or comment they want to share on the work, what your work environment is like. We'll make sure we get that question answered first.
I'll answer that one a little bit. Oh, go ahead.
Okay, I don't collaborate really with other chemical engineers. Like there's a certain amount of kind of individual contribution, but then most of my other work list is we have this thing going on. We need someone who understands this process unit, who's a chemical engineer, and they throw you in on a maintenance crew or an operations group or something else. And you're collaborating with people with a completely different background and understanding of the equipment. And they just need a designated person who's a chemical engineer, and you're collaborating. You may not even be doing chemical engineering work, but they just need someone who knows the process to go be a representative on a certain team.
That was additional question that came in a direct message is like, who do you work with every day? So Caleb, you're mentioning that like you might be the only chemical engineer called in to do something, but like who are the other people then that you're interacting with if they're not kind of chemies or the other engineers, technicians, other types of like backgrounds?
So my team is so I'm the chemical engineer. There's a mechanical engineer. There's a senior operator that's paired up. There's and then there's a production unit manager who either used to be an engineer or used to be an operator. And then that's kind of the core team. And then there's, maintenance coordinators and economics schedulers, people from basically every other aspect of the company that have some little integration with the process unit.
Yeah, it sounds like also intersect that operations versus process versus kind of maybe like blurring into the economics area. Yeah, sorry, I didn't mean to cut you off. I think you were.
Oh, no, you're good. There's other engineers that are in the building, and I talk to them at lunchtime, and we bounce ideas off of each other. But that's pretty much it. Like day to day, we don't. I call a senior engineer every once in a while if I have questions, but beyond that, it's collaboration with all kinds of different people.
Yeah, cool. Okay, thank you. That's like good perspective to have. Victoria, is it similar or different in your environment? And like, who are the people that you are working with? Like, what are their backgrounds? What are their training? And kind of what's your work environment like?
Yeah, so it is very similar in a lot of ways. We don't work with a lot of chemical engineers. We spend a lot of time more with maintenance operations. Although I will say there's two things with that. One is I spend a lot of time working with non-chemical engineers, but really I spend time working with essentially blue collar and then chemical engineers who have progressed further into their career. So a lot of the roles, economics, our technologists, our subject matter experts, they're chemical engineers who used to own units and then have moved on in their career. So they're more senior engineers. And then, so kind of similar. We kind of noticed there was a little bit of a gap, especially coming out of COVID, of chemical engineers who didn't have senior engineers to rely on or to talk to. So we intentionally pull all of our unit process engineers into a meeting once a week to talk and collaborate and discuss, hey, you're a chemical engineer, you're the only one who cares about this, but let's talk about it and share these experiences. So we kind of force interaction a little bit with like-minded people.
Yeah, that's I think like a cool thing to see in the industry setting that we don't always hear about is kind of creating spaces that sort of bring together people who might not otherwise interact, which I think is cool to kind of see an example of that, particularly in a large company, operationally sort of play out. One of the other questions that came in related to several comments that y'all made earlier, which is like, I'm gonna like paraphrase this a little bit, but do you get scared with the responsibility of making decisions? Like, because we've definitely had other panelists from who very early on get into kind of leading, a unit or leading a team or whatever. And so the accountability and responsibility is on you, right, to kind of be the decision maker. But then I think, Victoria, you also mentioned that you have to make decisions based on the information that you have on hand. So there's a lot of unknowns, in many cases. There's generally a lot of unknowns. How do y'all, is that something you kind of have to emotionally navigate? And what's your process for that? And I know that this might also elaborate on some of the sort of utilizing the resources that are in existence, right? Like the people resources and sort of structural resources, but is it scary? I guess is the starting point.
I'm going to jump in on that one. I'll tell a brief story, but it is very scary. I think I was 5 or 6 years into my career, so I would have been considered one of our most senior engineers. And we had an issue with a unit. It was a maintenance issue. We thought we came up with a solution, and it was primarily led by myself. It was kind of a collaboration to come up with the idea, but then I had to go through and vet, hey, is this feasible? Is there any concerns with this? We walked through it. thought we had a great solution, executed it, and the execution went really, really well until we had a fire. And I think the scariest thing for me was, I was sitting here trying to figure out what went wrong. How did we go from a flawless idea, first time we've ever done it, to now we have a fire? And my friend walked past me in the hallway, and I said, "Hey, can you help me with this?" And he says, "I can't. I have to go respond to the fire." And that's when it hit me. I was like, "Oh my gosh, I'm sending my friend out to respond to an emergency situation." And so that was terrifying.
Yeah.
This was, like I said, well into my career.
Yeah.
And the ultimate issue was the root cause of the maintenance issue was not something that we had ever seen before. I don't know if we ever could have identified the root cause, but it was not what we thought it was. So that led to a different situation and ultimately the fire. So that sounds terrifying, and it was scary.
Yeah.
But I also knew that the folks who were responding, they knew what they were doing. So I never felt unsafe. It was more of, I felt responsible, which is scary. So, and it actually took me a long time in talking with the people who were involved to understand that even though I was responsible in some ways, that was a good thing. That it was, I owned it, I cared about my people, and that's why I was upset. But that nobody held me accountable. It wasn't my fault.
Yeah.
And so working through that, situations come up. Like I said, you have the information you have at that time, and you make the decisions. You make good decisions as best as you can. They were vetted by other people. We went through all the right processes, but we were still incorrect in our initial assumption, and that's what led to the problem. And so for me, that took some time to adjust to initially in my career.
Yeah.
And then further into it as things came up. So
I think it's a great perspective too, though, to emphasize that there were people who were in their processes and people in place who also handle emergencies or scenarios, right? And so there was a team that could help address that. But
of course,
in many times there's also things that you just cannot predict. And so you have to kind of do your best, like you're saying, with the information you have on hand, and then trust that the people and the processes and the systems that are in place, if you've ensure that those are there and they're rigorous, are also going to do their job, which is address failure points when they happen, right? And there's no way to completely avoid all failure points. So I think that's also a good point that you've brought up, that there are mitigating 100% of issues is really difficult to do, and so there are these kind of ways to companies have to really address them. Caleb and Shannon, do y'all have also not everybody has to answer, and Victoria, I really appreciate you sharing this very specific example, because I think that always helps. Kind of oftentimes we'll hear, particularly I think I face this all the time with very senior people in academia, where they'll talk about oh yeah, we submitted grants for 15 years and didn't get any of them funded, and then suddenly I got it funded, and it's okay, but that doesn't really specifically tell me what you did or how you navigated that. So I also appreciate the specificity of the example. Caleb and Shannon, if you have any comments or anything to add, please feel free to share, but I can also happy to throw some other questions at y'all.
Yeah, I have two kind of short examples. I think the big pressures are process safety and cost. You could do something that hurts someone, or you could do something that costs the company millions of dollars, and both could be a simple mistake. So on the cost side, what kind of helped me work through, because it is very stressful when they tell you, if you get this right, you're going to save us $5 million. If you get it wrong, it's going to cost us $20 million. Right. And it's your call. You've got 2 years experience. You have to just kind of figure something out and use the resources around you. But what kind of takes the edge off of that is when you work through some improvement opportunities, and you can say, this big part of my career was spent on these optimization things that saved, $5 million a year going forward. And, not everything's going to be huge and glorious, but once you get a few things under your belt that say, okay, I've saved the company some money, I made a couple of mistakes that cost us some money, but in the end, it worked out. With process safety, though, it's different, because you can't just look at it like you win some, you lose some. And so what I've stuck to is I won't ever, a lot of times as the engineer, you have to tell someone, you need to go turn this valve, or this is about to happen. You need to go make some adjustment out in the field to prevent it. And so my philosophy has been, if I'm willing to go stand next to the guy that's turning the valve and turn it with him, then, I'm okay with that sort of risk. But like I had one actually just a few hours ago, a guy came up to my desk and he said, hey, this valve is leaking and this other valve is stuck. So we're going to remove the stuck valve on a live process and close it with a leaking valve, and the process is going to be blowing out, and we're going to look at the valve that we pulled out that's 3 foot tall, see if we can fix it, and then put it back in. And it was a question of, are we going to be able to keep running, or are we going to have to shut down to do this work? And you have to be the bad guy sometimes and say, I would not stand next to you while you pull that valve, so I'm not going to sign off on this form. And you have to explain to the business team that, yeah, this is going to cost us $2 million to shut down, but it's the right thing to do because someone's inevitably going to get hurt if you start opening live process lines.
Yeah, I think that's a great perspective to provide too on like where error or risk is acceptable, right? Like thinking about having more potentially of a cushion, for lack of a better word, and in terms of the economic side as opposed to the safety side. And you're right, kind of like, yes, there's a short-term impact of this, but the longer-term impact of loss of lives or permanent injury or something, like if we can avoid that, it's better to take the economic hit than to take the safety, right? Or the sort of personnel risk that would come with it. But I think it also highlights a point that I imagine all of you face continuously, which is this, you really have to stand by your ethics and right? Like these situations that there is not always a clear answer, and there are always going to be some disadvantages or shortcomings of any answer. And so really being able to sort of weigh what is the best way, and what are the impacts of that going to be, both good and bad, I think is a not uncommon process you have to go through, I would imagine, in your jobs on a day-to-day basis, week-to-week basis. And certainly I imagine risk also varies industry to industry, but it's still there, right? And sort of what you're having to decide. So I like also appreciate you sharing that level of nuance too, of thinking through, and the daily, the as of today example, which is really great to give like the true real time. Like this is something I was talking about literally hours ago. So I think that was great. That was great to share. I mean, I'm sorry you're in that situation, but I think it's great that you shared that. Shannon, anything that? Yeah, I was gonna say it's the nature of the job, right?
Yeah.
Anything you want to add, Shannon?
Yeah, actually, so I think my role is a little different than Caleb and Victoria's in that I do interface with chemical engineers every day. Like that is kind of like it's a little less maybe cross-functional in that I'm never on the floor actually. Well, sorry, this is gonna make me sound like I do nothing, but you know what I mean. Like I'm not like really.
I don't think anybody's gonna
with our like manufacturing or operations team. Like I'm strictly like I'm at my desk like all the time, and so I think for me, where kind of these high pressure situations is occurring is like this is a high volume manufacturing kind of facility, right? Like the main focus is throughput. We have to get a certain amount of wafers per day, but we have all these different kind of pillars where we have quality, we have safety, and we have kind of our process engineering teams, right? And they all have to work together in order to get these wafers out. Mm-hmm. And so I think where a lot of the pressure that I face on a day-to-day basis is, let's say my tool or my process isn't working. I'm constantly getting these OOC points, like my process is not in control and I don't feel comfortable running. And I have to make a decision where we're, to say I can't run, or we're lying down, and inhibiting the ability for wafers to move to the factory. And so I think then you have to report to leadership and why we're not making these moves, or the manufacturing team. So I think that's where it can be really high stress in terms of just having to answer and having to have a path forward, because you can't just say, well, I can't run. It's like you have to have an action plan, right? Like, what are you going to do? How are you going to solve this? And so just staying calm and just working through that, I think, is kind of the biggest pressure that I face day to day.
Yeah, and also I think like you bring up a really good point of the ripple effect, right? Like all of you have highlighted very important aspects where like you are you may be working independently, but what you are doing is a codependent component of a much larger process and operation. And so anything that happens in what you are overseeing could have a significant downstream or upstream effect, right, on everything else. And so having that be a consideration, and I imagine a stressor, as you mentioned, Shannon, in your day-to-day job is certainly something also to manage. I know we're coming kind of towards the end of the panel time. There's been a couple of questions that have come in to kind of connect this back to your ChemE education and kind of undergraduate training. I guess, while you were in undergrad, what were the experiences, the courses that you think have been most beneficial for you to have done? I guess you have the benefit of hindsight being a little bit 2020 here, but what are things that you did or places where you felt like it was a really good investment of time to build expertise or build experience? And if there's specific classes too that you really see are relational, like directly relational or in support of what you do day to day, whether that's elective or core courses, those would be great to highlight, because I take notes and put all this up afterwards so people can kind of connect across like their current training and current curriculum. Maybe we'll start with Caleb. Do you want to take a stab at that first, Caleb?
Quick answer. Heat transfer, fluids, and controls I use every day. The others, maybe once a month here and there.
Right.
There's a lot of stuff that you just learn on the job. They'll give you a proprietary technology that you have to learn their computer program, and you just do things to the job. Like, yes, you're a chemical engineer, but you're also part of the business, and they often ask you to do things that are outside of the core stuff. But those three are the big ones that are, at least in the refining environment, every single day. You're using some aspect of that.
And I know you mentioned your high school experience, but like shadowing experience, were there like research internships, elective classes that you kind of chose to explore that even if you don't use day to day were just really informative for you to have, or kind of, complementary to just your general interest?
I mean, me personally, I was in a rush to graduate, so
yeah.
I took as few
You're like, I'm
electives as
getting out of here
possible.
as quick as I can. Nice. Hey, that's a great answer too. I think that's like that's a very relatable answer to many individuals. Victoria, what about you? What classes, either ChemE or elective, and experiences? I know you mentioned all your internships, but were there other kind of curricular or UW-based experiences that you really find yourself going back to or kind of can connect to?
Yeah, I mean, a lot of the core ChemE classes. I also use a lot of thermo. Separations, depending on the unit you're in, that's important.
Yeah.
I loved the class, but I don't use a lot of reaction kinetics because what we do tends to be far more complex, and like Caleb was saying, it's in softwares already.
Right.
The other experiences and things I've seen, what differentiates an engineer versus a really good engineer is any extracurricular or external activities that aren't engineering based. I see a lot of gaps in soft skills, communications, learning the ability to persuade people who maybe don't understand the technical aspects or who are focused on something different, persuading them to see where you're coming from and why your position is important. So for me, I was in the UW ChemE Car Club. I led that for a year.
Yeah.
And so that was a great experience to work on, how do I work with people who disagree with me, and really force some of that. So I think that experience was a big help for me, at least.
Yeah, I also love that you mentioned like non-engineering based experiences, like bringing in that creative, but also the soft skills in different ways that are not the technical kind of structured aspects that many of our engineering and STEM courses can be designed around. Shannon, what about your connections to your undergrad ChemE program? I appreciate that none of you have been like, I ignore all of it and I don't care.
No.
That's great.
Yeah,
so thank you.
For me, again, like CVD processes, like this isn't a plasma chamber, right? So thermodynamics is really important, heat transfer, understanding, even fluid dynamics. I think all of the core ChemE courses are really, like, I'll be honest, I'm not take like busting out Bernoulli's equation every day and, doing calculations. But, like, I think obviously the fundamentals and understanding is like very key. How is temperature and pressure going to affect the reaction? The surface limited, that kind of stuff. And then I think what I really like that Victoria touched upon was communication. I think what you'll find as you enter the industry is that people can be really, really smart, but communication and those kind of soft people skills are not always super developed. And I think having and being able to, convince other people, you're in a room and you're trying to do some kind of conversion and just be able to speak up and communicate clearly. I think that can go a really long ways in addition to technical skills.
Yeah, I also I really like, and I'm just gonna, this is for everybody in the audience. We have, as I mentioned last class, do not pay our alumni speakers to say anything, but y'all are probably the first panel that has emphasized the extent of our junior core courses more than our senior core courses in a way that's directly related to your job. And so I really just appreciate having that perspective, because I think it's easy to kind of often find relations in some ways to our senior core, which are very applied, but really showing kind of the importance of those fundamentals and how that factors into thinking about decision-making, risk, impact, all of that, right? I think it's just really cool to hear about. And for everybody in the audience, since we're coming to our last minute, I've taken notes on all the courses, the experiences, the student organizations, anything like that that's mentioned will go into the bottom of the reflection post that you'll have after today's panel. So if you want to sort of just see or get linked to any of the things that Caleb or Victoria or Shannon have mentioned, those will go, as always, in the notes at the bottom of the reflection post. But since we're at our class time, if everybody can join me in giving a virtual, whatever emoji response you want to use in your reactions, round of applause, whatever else, thing to our panelists. We'll thank them very much for their time. Thank you everybody for sending the direct message questions as well. We really appreciated Victoria and Caleb and Shannon, y'all taking the time today to join us and share with us about all the cool things that process engineers get to do. Yeah, it was really fun, and we just appreciate you doing that. And we'll let all the students go and get to your next class or whatever else you have next, and then Caleb and Victoria and Shannon, if you don't mind hanging around for a hot second, that would be great. Just so I can ask you a few follow-up logistics questions, not anything serious or major. We'll let everybody get off first. So I usually follow up with just a quick email, obviously thanking you for your time, because that we're very grateful for. If you don't mind or would like to share an address so we could send you just a small thank you, that would also be great. Not required if you're not comfortable sharing an address. And then the other thing that I'll follow up with an email is just any remaining questions that didn't get answered, or if you're willing to be contacted through me or Dave to help facilitate a one-on-one sort of discussion or one-on-one mentoring session or anything like that, I'll follow up with that in email as well. And again, literally no pressure to respond to any of that or to engage with any of that. It's just if it's something that you enjoy doing and want to do or want to have as a way of engagement, I want to make sure I don't overlook that potential forum of engaging. But I really think y'all are awesome. Thank you so much for taking your time.